I open the YouTube. Right. So I do nothing on Zoom, right? Zoom is
No,
just
no. Yes, sir. Yes, sir. Nothing on Zoom, sir. So we are live now. You can check that page, sir. YouTube page.
Yeah, correct. I can see Nandita also in the YouTube.
Yes, sir. Can you mute the mic in YouTube, sir?
On Zoom.
Yes, sir.
Sorry?
So, yeah, you have to disable that audio in YouTube, sir. Otherwise, echo will come, sir.
So open the YouTube. Right. Done.
Yes, sir. So we are live, sir. You can start, sir. I will mute myself, sir.
Okay. So officially welcome to the live session, actually the first live session of the course Introduction to Astrophysical Fluids. And so I was really happy to see that 733 students registered, despite the course was for specialized students. So I firmly believe that that was simply due to the, increasing attraction towards the domain astrophysics for the, undergrad and graduate students. And it is also true that for the students who are doing astrophysics course for the first time or fluid dynamics course for the first time, it may have some blockages in some parts, but believe me that if you just then see the circuit of logic of the course, you will find almost very little problem. Okay. Of course, one thing is very important in the whole course, that there are so many mathematical details which I skipped deliberately. So by the end of the 9th or 10th week, maybe 11, yeah, by the end of the 10th week, I will send you some handwritten notes, okay, which I made when I gave those lectures in IIT-Kanpur. So that I will send you, where you can see there are so many calculations. Already they have been done over there. So which I actually sometimes suggested you during the lectures. Okay, so many things can be clear, but these things are very, very interesting and very, very useful if you are continuing in this domain. But once again, don't get afraid of the mathematical rigor and the mathematical details. The basic objective of this course is to get you motivated or motivate you towards making a career in astrophysics, either from the fluid dynamics perspective or in the spatial, like the evolution perspective, okay, whatever be that. Okay, so that's the main objective of the whole thing. Now, so since I cannot see till now any question from the students, before answering some questions you already asked me on the forum, maybe I can just tell you one or two sentences about the exam. So the exam will be purely MCQ or MSQ based. That means there may be, the questions will be multiple choice or multiple select type of questions. So you can have one or more than one correct type of answers. So, and the exam will be totally depending on the course content. So as you know, like almost 50% questions will be really known if you can regularly follow the lectures and do the assignments. So no problem with that. The rest of the 50%, well, this will also can be including some very common sense based questions, intuitive questions, some questions which can be, solved just using two or three steps of small calculations, really small calculations. Okay, maybe only, only 4 or 5 questions out of the whole set of questions will be a bit tricky in the sense. But well, for obtaining a certificate, as you know, this will not really play a very important role. So that's what I am saying, that just by seeing the mathematical part, so the mathematical part I always maintain there, so that the people who are really, who really want to follow the course, okay, to do advanced research or advanced study in this domain, for them. But of course, if you have just enrolled for having an essence of astrophysics, this is not essential. Okay, this is not essential. Of course, I mean, you all agree. I mean, we all agree that for a physics student, having a mathematical shape is always useful to understand the concrete logical part of some phenomena or some explanation, right? Rather than interpreting in a hand waving way, right? Sometimes we, of course, do that. Okay, so that's one thing. So Yash is the first question. So is there astrophysics course at IIT Kanpur? So yeah, so there is an astrophysics course which is mostly like astrophysics with the high energy particles. So that's in a proper sense, proper astrophysics course, which is taken by mostly by Professor Pankaj Jain or other people who, yeah. And I am the first one who proposed this, I mean, who, sorry, not proposed, who taught this course in this, yeah, at IIT-K. This is the fluid dynamics perspective of astrophysics, so that we can actually rather to know about the details of the astrophysics, the energetic or the evolution perspective. Here we are interested in the fluid perspective. That is the dynamics. Okay, so yeah, so these two courses are now there. Of course, you know that they are, none of them are yeah, right, none of them are compulsory in a sense, so they are elective courses. Yeah. So before I get some other questions here, let me address two questions, very good questions, of course, from Vishwakannan RK. So he's a student, and he asked me that, of course, from his question, it is very evident that he is a student of astrophysics, or he is a student who has a passion in astrophysics. So his first question is, let me just go, yeah. You said that the extragalactic jets find the path of least resistance. I mean, well, this is a way of saying, I mean, it's an analogy, okay, which is the area of least thickness, which acts as the Dulaval nozzle. Okay, well, okay, this is also roughly correct. But mass in elliptical galaxies is symmetrically distributed. In that case, how can the idea of Dulaval nozzle be extended to elliptical galaxies, which are the sources of many extragalactic jets? First answer is that this is a, I mean, first comment is that this question is very important, but maybe not for this course. However, this course, for this course, what I can just tell you that, at least, so when we say that the mass distribution is uniform, this is in an average sense. Okay, so there are 2-3 elements of this question, so I want to highlight some of them. Now, even in uniform, I mean, even in elliptic galaxies, you can see, so of course, people who are not of that domain, they don't know what is elliptic galaxies. So in general, all the galaxies are classified into 3 broad classes. Okay, one is spiral galaxy, that's our Milky Way, you can think of. Another is lenticular galaxy. Okay, another is elliptic galaxy. So elliptic galaxy should look like a rugby ball, like an ellipsoid. So there are active galactic nuclei, and whenever you have that, you have a local rising density. So very local to that nuclei, you can always have this very rising, I mean, sudden rise in density, and just in the neighborhood you have a sharp fall in density. So the people always, so the jet, if it is produced in some way, at least from our framework, we can say that in the very proximity of that active galactic nuclei, you can always think of a creation of very local Dulaval nozzle. But this is true that this is difficult to, I mean, like how to say, bulk-wise Dulaval nozzle is difficult to be thought in case of elliptic galaxy. That I agree. So there are some points of that. Some people say that, well, there are rotations. So that's why, although there are mass distribution in some directions are preferred. So this type of things are there. Of course, in the whole discussion, I totally skipped about the relativity of the particles and the charge of the particles. First of all, don't forget that galactic jets are plasmas. So when I will introduce plasma, you will see that maybe I will say one word of that. So, so there are actually plasmas, and the plasma and some particles are actually in practice relativistic. For example, the electrons. Okay, so their behavior is different. So something can be caused by that. Okay, some local pressure, ups and downs of the pressure can be caused by that. Okay, so it is very true that till date there are one or two papers. I don't want to cite the papers in a course like that, which is mostly, and I mean with some, I mean mostly with a vast audience with different interests or different backgrounds. But just to tell you that researches are going on, and we are still not 100% clear, as you said. But locally, the level nozzle can be thought of. The second question is much more tricky, and to be honest, the second question is not very easy to answer. So, what is the okay? The first one is okay. What is the source mechanism for emission in radio waves by extragalactic jets? So once again, I have to use the concept of plasma. Here in this framework, I gave you the example of extragalactic jets or the Laval nozzle just by a neutral fluid, and which is no longer true actually for a practical extragalactic jet. So then there actually we have to consider the electrons and their synchrotronic type of rate. I mean, so the gyro, I mean, how to say that? Gyrotropic motion, maybe. No. How did it say that? So, I mean, the synchrotronic motion, okay, with a gyro radius around some magnetic field direction. Okay. So, and this electron should be then relativistic. And you know that when some particle is actually rotating like that in classical electrodynamics, okay, what does it do? It radiates. So that is the one of the very popular theory of that. There are other theory like nonlinear coupling of the plasma. So to be very honest, your question can apart be answered. The second question answered after I talk about plasma. So maybe in the next live session, I can tell it with much less hesitation, because by that time you will be introduced to plasma. Okay, so that is the one thing. So just in the meantime, maybe if you are interested, you can see papers. There is one paper by Meyer in 2012. Yes, other thing I really not made sure, but yeah. So you can also search for the things like nonlinear. Heating due to, radiation due to nonlinear coupling in plasma. Okay, this type of thing you can search for. This is highly non-trivial domains of plasma physics. Let me tell you, I personally am interested because I do plasma turbulence as my research, one of the research topics. So I can tell you something, but in the next live session maybe. Now your last question, unfortunately, is also not known by me. As you say, also it's not known to me. So the thing is that why in M87 only we have optical range of radiation, and for the most of the others we have radio? I don't know. Maybe some other people can know that. So I actually, after you asked me this question offline, I searched various sources, and finally I also could not found that very critical. Of course, it depends on the variation of the energy sources, but the energetics part is very complicated, and this is a subject of ongoing research. So yes, for that I don't know the proper reason. So of your three questions, the first question is very, very good question. So the first question is more or less answered. The second one I will answer in next live session. The third one I don't know the answer. Okay. So we're coming back to other questions. So if you guys have any other questions or any other things to ask. So I am waiting for your questions to come. And yeah. So if you want me to explain something or re-explain something, or both for science and organizational things, I will be happy to. Yes, So Yash again. So Yash, thank you for asking me the questions. It feels good that someone is listening. Okay. So if you have any doubts, kindly post. Yeah. Okay. So can magnetic fields of very compact object can act as deliverable nozzle? That is, they accelerate the fluids to very high speed. Maybe can magnetic field of very compact object can act as a there this is also critical. This is also critical. There are so many things, magnetic, not only magnetic field, I mean actually the rotation. So maybe if you remember that uh, so I mean yeah, so as you correctly may have mentioned that a very compact object, so for example a neutron star or even a black hole, so the rotation actually, so the rotation is actually much more sometimes important. So it's true that we don't have nowadays 100% a concrete theory, but well, rotation is one of the very potential competitors or candidates. I mean, to accelerate the fluids very high speed. Yeah, and you are talking about supersonic. I am talking about even relativistic speeds. Yes. So in practice, they are becoming relativistic. Okay. One question. Uh, I mean, this is. I don't know how many of you are attending this live sessions, but one question, just you can also think that we sometimes talk about the supersonic things and this in non-relativistic cases. So just go through a bit about the relativistic cases and see that whether what we say for non-relativistic gases supersonic, is it still supersonic for relativistic gases? Because in relativistic gases, the polytropic index changes. For example, the adiabatic polytropic index of a monatomic gas is no longer 5 by 3 but 4 by 3. Okay, for electrons, for example. Okay, so and from that you try to calculate maybe some estimate for the sound speed and try from there to check that whether, so search for some typical values. Okay, and from that if you know the temperatures of gamma T by m, you can take the root and you can obtain the sound speed. So this is a good exercise, huh? So I mean, just check. So whether a supersonic or subsonic thing in non-relativistic gas still remains supersonic or subsonic respectively in a relativistic gas. Okay. Okay, so yeah, you are right. So the compact objects participate in some ways, but they are not really, I mean, not really the magnetic field. Sometimes magnetic field, I agree. Sometimes the rotation is also important. Yeah, magnetic field. So yeah, there are simulation results. There are simulation results. Yeah. Any other questions? So maybe I would okay, yeah, thank you. So maybe I would really prefer that you guys, if you have some questions related to the course, okay, so which can be helpful even for your exam. Okay, so I mean, advanced questions are always welcome because I will be happy. But for you guys, maybe this is a very important that we talk about a bit, which I already talked in the lecture. Or if you say, sir, 100% was very clear, I will be the happiest person. But I know that it is never true, right? The 100% cannot be clear. So, yeah, something from the lectures. Any other people, any other question? So just in case you are interested about the organization, so from next week I will start. So next week I will complete rotation. I mean, yeah, complete the rotational part, and so I will just show roughly the theory of self-gravitating mass under rotation, which is the realistic case. After that, I will enter into the plasma. I will give you some superficial introduction. A deep introduction is not possible, and my magnetohydrodynamics, which is the monofluid model of plasma. And then I will switch to my own research interest, that is the turbulence in astrophysics. And finally, in the final week, so the final week also, I will discuss some turbulence. And finally, I will close the course by giving some very introductory concept about dynamos. Okay. So any other question or any other doubt? So yeah. So in the forums, sometimes you used to ask me some questions which were not really easy to write in one sentences, because either they are coming from a very basic deep understanding, or sometimes this is difficult to write in words. And in general, can magnetic fields act as a CD nozzle for not for combat? I don't know that. I don't know that. Let me. Yeah, yeah. Okay, okay. I understand what you are saying. Um, I cannot. So you mean for plasmas, right? So I have to check because the temperature of the laboratory plasma um, they are not very high. Of course, the electrons are always with a very high temperature, but I have to check. Okay, it's a good question. So the laboratory plasmas are known as cold plasmas. Okay, because I will talk about that later. Okay, but to be very honest, yeah, I don't have the answer now. Right now, I have to think. Yeah, whatever. Yeah, right. Yeah, plasma, ionized gas, whatever. The main question is that the plasma is cold plasma. That means the ions which are giving the inertia, they are actually cold. Cold means the temperature is almost like the room temperature. So how many and so I mean, it is true that if you just give a magnetic field, you all know that what should the charge particle will do. It will just gyrate first of all, right? This type of thing. So this is the first and foremost thing. That whether it can accelerate in some, I mean, I am thinking in terms of other coupling forces. That I don't know. That I don't know. Okay. Okay, let me check, huh? Let me check and tell you in maybe in the next live sessions or in a forum. So just remind me after 2 or 3 weeks. Okay, yeah. So any other questions, preferably from the course content? So any other persons? Then Yash, are you listening? I mean, so any question or comment? Okay, so if I don't know. Yeah, that's okay. I mean, that's very normal. I mean, Josh wrote just he's a bit lagging behind. I mean, that is nothing to worry because we are all lagging behind the course if the course is, offline. That is a general case. That's not a problem. Yeah, but go for the exam. Huh? The exam will be very easy. I mean, I am really inspiring you guys because the exam will be containing questions which will be very easy to answer. And if you have just worked a bit about the assignments, I mean, worked a bit on the assignments and also about the lecture. So, yeah. Okay, any other questions? I cannot see any other people actually. I don't know. Like, so Of course, content-wise, this is a heavy course, but yeah. Let us wait for 2 to 3 minutes. Yeah, sure, sure. I don't have any problem. So, yeah, okay. What else? Yeah, yeah, sure, sure. You can end it. Yeah, no problem.
Sir?
Yeah,
Yeah, can I end the session, sir?
yeah, yeah, please. Okay, okay. I should leave that, right? Okay.
Yes, sir. Okay, sir.
Okay, okay. Thank you.
Thank you so much, sir, for your valuable time.
Okay.
Yeah,
Bye.
thank you, Nandita.